Good morning, sir. So this morning, my topic is about Boyle's law. So in Boyle's law, I have three problems here. So this is in module 3. So now, this is in module 3 and culminating activity. So in Boyle's law, remember that in temperature is always constant. So our equation here is pressure 1 times volume 1, then pressure 2 times volume 2. So what we are going to do here is to solve this problem. Number 1 is a 25 liter container has a gas pressure of 4.6 atm. So if the volume is decreased to 1.6 liter, what will be the new pressure inside the container? So they're asking what is the new pressure inside the container. So first we are going to analyze this problem first. So 2 liter meaning to say this is the volume. So the first volume meaning to say volume 1, V1. This is the value. So we are going to find the pressure 1. So our pressure 1 here is 4.6 atmosphere atm. Now our volume 2, our V2 here is 1.5 liter. 1.6, this one 1.6, I mean 1.6. This is our volume 2. So now we have the value of volume 1 and volume 2 and pressure 1. So what we are going to find here is the pressure number 2. So our pressure number 2, we are going to solve it so by using this equation. So now P1 V1 equals P2 V2. So the value of our P1 is 4.6 atm atmosphere. Then the value of our V2 is 2.5 liter. V1, I mean V1. Then the value of our pressure 2 is unknown. So that's why we are going to find the value of this. So the V2, the value of V2, the volume 2 is 1.62. 1.6 liter, I mean liter. So now this one is liter. So now we are going to multiply 4.6 times 2.5 equals 11.5. So equals 1.6 the liter. We are going to multiply, write down here, divide. So 1.5 divide 1.6 divide 1.5, then over 11.5, then divide 1.6. The answer is, but first before that we are going to cancel this one, 1.6, then write down here the pressure 2, then equals 11.5 divided by 1.6. The answer is 7.19 atmosphere. So this is our answer in problem number 1 according to Boyle's law. So now this is the answer in number 1 problem. So our pressure 1 increase. Our pressure is increasing because from 4.6 now 7.19. So meaning to say our pressure increasing. So the next is problem number 2. I forgot. So problem number 2. So in problem number, the air inside a flexible 3.5 liter container has a pressure of 115 kPa. So what should the volume of the container be increased. So in order to decrease the pressure to 625 torr. So now we are going to use this equation P1 V1 equals P2 V2. So in P1 equals 100, the value of our pressure 1 is 115 kPa. This is a constant, kaning absolute because kPa. So the volume 1 is 3.5 liter. Our volume 1 3.5 liter, this one. Then our pressure to 625 torr. So we have here the torr, 625 torr. And then our volume to is unknown. So what we are going to do is we are going to find the value of our volume 2. But before that, we are going to convert kPa to torr. So 115 kPa is equals to 1 kPa. The conversion of this in 1 kPa we have 760 torr. So now we are going teka, in 150 in 101.3 kPa is equivalent to 760 torr. So what we are going to do here is we are going to cancel out this one kPa, and then 115 times 760 torr divided by 101. The answer is 862.8 torr. So this is the answer. So now that is not the final answer. So what we are going to do, we are going to write down here our pressure 1 862.8 torr. Then our volume 1 3.5 liter is equals to our pressure 1 pressure to 625 torr. Then our volume 2 is unknown. So now we are going to multiply this one. So 862.8 times 3.5 liter is the answer is 3019.8. So equals to, write down here the pressure 2 is 625. Then we are going to divide by both sides, 625. So cancel, then copy right the volume 2, then 3019.8 times divided by 625. The answer is 4.83 liter. So meaning to say our volume is increasing, because before our volume is 3.5. So now our volume 2 is 4.83, meaning to say the volume is increasing. So the next problem is in problem number 3. So here we are going to solve also and give the solution of this problem. So now in Boyle's law, the volume of a gas at 17.5 psi decrease from 1.8 liter to 750 ml. So what is the new pressure of the gas in ATM? So now we are going to find the value of P1 equals 17.5 psi. Our P2 is unknown. So our V1 is 1.8 liter. So our V2 is 750 ml. So we are going from ml, we are going to convert to liter. So what we are going to do here, we are going to convert. So how to convert? So first, before that, we are going to convert. So from liter from ml to liter. So but before that, we are going to give a conversion here. So this one. 750 ml in 1 liter is equivalent to 1000 ml. So what we are going to do here is we are going to convert. So write down here, because ml, then 1000 liter, 1000 ml equals 1 liter. So cancel ml, cancel. Then we are going to, because divide, because this is a 1000 is a denominator, place in denominator. So this one, 750 divided by 1000, the answer is 0.75 liter. So this is the replacement of this ml, 750 ml. So the replacement is 0.75 liter. So our volume 2 is 0.75 liter. So now what we are going to use this equation, P1 V1 equals P2 V2. So our V1 is 17.5 psi, our V2 V1 is 1.8 liter, equals, since our P2 is unknown, so we are going to proceed to V2. So our V2 is 0.75 liter. So we are going to cancel this sign, unit liter and liter. So we are going to multiply this one, P1 and V1. So the answer is 31.5. So equals to, write down, copy here the volume to 0.75 liter, and then divide by both sides. So 0.75, then cancel liter, this one cancel. So our P2, but before that we are going to divide. So 31.5 divided by 0.75, the answer is 42 psi. So our psi here is, our pressure 2 is 42 psi, but we are going to convert into atmosphere, because the question is what is the pressure of the gas in atmosphere. Since the question in the problem is atmosphere, so we're going to convert from psi to atmosphere. So the conversion factor to psi to atm, so remember that in 1 atm is 14.7 psi. So in 42 psi here, 42 psi, then we are going to divide, because the 14.7 psi is in the denominator, so we are going to divide. So 42 divided by 14.7, the answer is 2.86 atmosphere atm. So that is our new pressure. So that's all. That is the answer of problem number 3 in Boyle's law. So that's all, sir.